the momentum of a photon. Let's do some mathematical playing around. Momentum equals mass times velocity. Now, there's an energy mass equivalence, and let's use that for a light photon. M is equal to E over c squared. Well, let's put E over c squared into this equation. So we replace M with E over c squared, the mass equivalent. Now we're dealing with a particle of light, a photon, and the velocity will be c. So let's change that to c. Now we already know the energy of a light photon is h times f. So let's replace E with hf. Very simple. Now watch what happens. We have hf over c squared times c. Well, let's cancel out those c's, and we have hf over c. In other words, the momentum equals E, the energy, over c. But that's not how we normally write it. Recall that the light particle, the photon, frequency is c over lambda. This is what we normally do. So c over lambda will go in for f. Therefore, I will have hc over lambda c. The c's cancel out. And look what I'm left with. The momentum of a photon is h over the wavelength. Now, this was confirmed in the 1920s by a man named Compton. And here's what his experiment was. He collided a photon with an electron that was at rest. And when he collided that photon with the electron at rest, there was a collision. And the electron moved off, and the photon was scattered. Now it looks like what we see in collisions. And the photon had a certain frequency, but after the collision it had less frequency, a smaller frequency. And lo and behold, this collision obeyed the law of conservation of momentum. Photons have momentum. They behave like particles. Well, another man named de Broglie, Louis de Broglie, thought the other way around. He said, okay, if a light photon can have a momentum and it's h over lambda, what if I rewrite this equation and I end up with the wavelength equals h over, hey, let's put in momentum of a particle, mv. The wavelength equals h over mv? Well, this also was confirmed by experiment, as they found protons, neutrons, and electrons had wavelengths. And so do you and any matter that is moving.